Hi everyone, and welcome to Sweet Math. Today we have another fun geometry challenge. In this problem, we have a large square, a smaller square, and a circle. As shown in the figure, the large square has a side length of 6, while the smaller square has a side length of 3. The question is, what is the area of the circle? Before we dive into the solution, I encourage you to pause the video and try solving the problem on your own. Once you've found an answer, leave it in the comments below. Now, let's solve it together. Our first step is to draw the diagonal of the smaller square. Let's call its length d. Next, draw the radius from the center of the circle to the point where the circle touches the smaller square and label it r. Finally, connect the center of the circle to the bottom left corner of the large square. Let's call this segment x. Now here's an interesting question. Are these three segments, D, R, and X, all on the same straight line? Let's prove it. A well-known property of a square is that every point on one of its diagonals is equidistant from the two adjacent sides. Let's examine the two key points. First, consider the point where the smaller square touches the circle. Its distance from the left side of the large square is 3. And its distance from the bottom side is also 3. Since these distances are equal, this point must lie on the diagonal of the large square. Now consider the center of the circle. Because the circle is tangent to both the left and bottom sides, the center is exactly r units away from each of those sides. Again, the distances are equal. Therefore, the center of the circle also lies on the diagonal. This proves that the segments D, R, and X are all collinear, and together they form the diagonal of the large square. Now, let's calculate D. Since D is the diagonal of the smaller square, it is also the hypotenuse of this right triangle. Applying the Pythagorean theorem, the square of the hypotenuse equals the sum of the squares of the other two sides. So, D squared equals 3 squared plus 3 squared. Therefore, d squared equals 18, which gives d equals the square root of 18. Notice that the point where the circle touches the smaller square is also the midpoint of the square's diagonal. That means these two segments are equal in length. So x plus r equals the square root of 18. Rearranging the equation gives r equals the square root of 18 minus x. Now let's move on to the next step. Draw the radii from the center of the circle to the 2 points where the circle touches the sides of the large square. The angles formed at the points of tangency are right angles. Why? Because a radius drawn to a point of tangency is always perpendicular to the tangent line. Once again, we have a right triangle. Applying the Pythagorean theorem, the square of the hypotenuse equals the sum of the squares of the other two sides. So x squared equals r squared plus r squared. Simplifying, we obtain x equals r times the square root of 2. Now substitute this expression for x into our previous equation. This gives r equals the square root of 18 minus r times the square root of 2. Move all the terms containing r to one side. Factor out r. Then divide both sides by 1 plus the square root of 2. This gives us the exact value of the radius. Finally, the area of the circle is pi times r squared. Substituting the value of the radius into the formula, we find that the area of the circle is approximately 9.7 square units. I hope you enjoyed this geometry challenge. If you found another way to solve it, let me know in the comments. And if you enjoy geometry challenges like this, don't forget to subscribe to Sweet Math. Thanks for solving it with me, and I'll see you in the next challenge.